Hello, everyone. So today what we are doing is we are going to learn about how we are going to do our homework assignments when we have a chapter and lesson reading in science. The first thing we need to do is you're going to either need to grab a notebook or some loose leaf paper, and you're going to want this to be separate from your bell work because in bell work, you might only need like maybe 10 pages for the whole year, but with this, you're going to need multiple pages throughout the year. I might even have a whole separate notebook or a whole separate section of loose leaf paper just for science. If you should have had that from your school supply list, if you don't have a notebook, either talk to the office or talk to your science teacher. We do have extras. First thing that we want to do, and I already have some of this information added on here just so you don't have to listen to me writing everything, is this. So first, please put your name at the top and then put when this assignment is due and then what hour you have science class. The next thing is to write down what the assignment is. So what is the chapter and what lesson is it? So this one's going to be Nature Science Lesson 3, and it's the bridge failure. We will have other ones that are actually in a chapter. So like we could have C1L1, so chapter 1, lesson 1, and that one's describing motion. You don't need to write this. Now, that one is one of our first lessons we'll do. That's more content, like of forces in motion, but that's what you just write. Chapter 1, lesson 1 would be good for that. So with that, we've got our papers started. Let's head to our science textbook. If you did not yet watch the video of like our science textbook basics, please watch that video because I show you how to turn on different things, how to zoom in, how to get to things. Watch that first. Heading it to it right now, you now should know that you can use this link to head to your science textbook. You're going to need this username and password to log in. It is not your typical username and password or your typical email. It says email here, but your email is not attached to this in any way. So make sure you use the username and password that I sent to you because that's what will work here. And if you're wondering who this Tyler is, it is my brother. I just made a kind of like a practice account, but I had to name it something, so I used him. When we get here, we're going to want to go to launch, and then we're going to head to the ebook for today. And where this one is sitting is it's Nature Science Lesson 3. It's the bridge failure. So we're going to want to go to, if yours doesn't start at the beginning, it's super easy to get to. Just go up to the contents. And mine's not starting there. Contents, it's under scientific problem solving. Hit the little arrow, and we want to go to lesson 3, the case study. And here's where it says case study, and at the bottom, that's where it's NOS, so Nature Science 3. Some things I'm going to do right away is I want the audio icons off. You can use them if you would like, if you don't want to hear me reading over these. And I'm going to zoom in just a little bit here so I can read it a little bit easier. Now, the first thing you want to do when you start is if you see on this far kind of left-hand side in the middle, there's the vocabulary. That is what you need to start with, is adding that vocab at the top of the assignment. The next thing that would be good to do is to go to the end of the text or that lesson and look for the questions that are going to go with this assignment. So wherever it says like that lesson and then the review. These are the questions we're going to be looking to answer after we're done with this. So, using vocabulary, distinguish between qualitative data and quantitative data. Contrast variable versus independent variable and dependent variable. Understand key concepts. So, constants are necessary in a controlled experiment because without constants, you would not know which variable affected the blank. Give an example of a situation in your life in which you depend on adequate testing and evaluation in a product designed to keep you safe. We're going to need to interpret graphics, summarize, copy, and fill in the flow chart below, and summarize the sequence of scientific inquiry steps that was used in one part of the case study. And then critical thinking, analyze how the scientific inquiry process differs when engineers design a product, such as a bridge, and when they investigate design failure. Evaluate why the gusset plates were such a critical piece in the bridge design. And 8, recommend ways that bridge designers and inspectors can prevent future bridge collapses. So those are ones we can kind of keep in the back of our head because those are ones we're going to need to answer for homework. So first things first, if you did not yet write down your vocab words, please do that. And something that I did, so you're going to see I've written with marker just so it shows up a little bit easier on my doc cam for you guys to read. But I have them all there, and usually I use like pencil or pen, and then I go through and highlight it. So I did still use a highlighter to highlight each of the vocab words, and as we come across those, we're going to add those, and then we'll answer the questions at the end. So without much further ado, here we go. Case study. The Minneapolis bridge failure. On August 1st, 2007, the center sections of the Interstate 35W, I-35W bridge in Minneapolis, Minnesota, suddenly collapsed. A major portion of the bridge fell more than 30 meters into the Mississippi River, as shown in Figure 7. There were more than 100 cars and trucks on the bridge at that time, including a school bus carrying over 50 students. The failure of this 8-lane, 181-milliliter long interstate bridge came as a surprise to almost everyone. Drivers do not expect a bridge to drop out from underneath them. The design and engineering process that bridges undergo are supposed to ensure that a bridge failure does not happen. Controlled experiments. After the 2007 bridge collapse, investigators had to determine why the bridge failed. To do this, they needed to use scientific inquiry, which you read about in Lesson 1, or we've talked about in class. The investigators designed controlled experiments to help them answer questions and test their hypotheses. A controlled experiment is a scientific investigation that tests how one factor affects the other. You might conduct controlled experiments to help discover answers to questions, or to test hypotheses, or to collect data. We'll be doing a bunch of those this year. So, identifying variables and constants. When conducting an experiment, you must identify factors that can affect the experiment's outcome. A variable is any factor that can have more than one value. We're going to need to add that to our vocab. So, at this time, pause the video, and you can add that after variable. So, mine says any factor that can have more than one value. Continuing then, pause the video if you need to. There's two kinds of variables. The independent variable is one factor you want to test. It is changed by the investigator to observe how it affects the dependent variable. And then the dependent variable is the factor you observe or measure during an experiment. Constants are the factors in an experiment that do not change. Lots of vocab there. Take a minute, pause the video, and add those things. So you've got all the way up to dependent variable. You've got variable, constant, independent, and dependent. Pause video, come back when you're ready. So then, experimental groups. A controlled experiment usually has at least two groups. The experimental group is used to study how a change in the independent variable changes the dependent variable. The control group contains the same factors as the experimental group, but the independent variable is not changed. So, two more vocab words there that we can add. Experimental and control group. Pause the video again if you need to. It is impossible to know whether experimental observations result from the variable you are testing or some other factor. This case study will explore how the investigators used scientific inquiry to determine why the bridge collapsed. Notebooks in the margin also identify what a scientist might write in a science journal. The blue boxes contain additional helpful information that you might use. So after I read these, you can go back and read those. It's just like a little bit of clarification there. So simple beam bridges. Before you read about the bridge collapse investigation, think about the structure of bridges. The simplest type of a bridge is a beam bridge, as shown in Figure 8 below. This type of bridge has one horizontal beam across two supports. A beam bridge often is constructed across small creeks. A disadvantage of a beam bridge is that they tend to sag in the middle if they're too long. Next page. A truss bridge. A truss bridge, shown in Figure 9, often spans long distances. This type of bridge is supported only at its two ends, but an assembly of interconnected triangles or trusses strengthens it. The I-35W bridge, shown in Figure 10, was a truss bridge designed in the early 1960s. The I-35W bridge was designed with straight beams connected to triangular and vertical supports. These supports held up the deck of the bridge or the roadway. The beams in the bridge's decks and supports came together at structures known as gusset plates. Do you remember me saying something about that when we looked at the questions for later today? Shown below on the right. These steel plates join the triangular and vertical truss elements to the overhead roadway beams. These beams ran along the deck of the bridge. This area, where the truss structure connects to the roadway portion of the bridge, at a gusset plate, is also called a node. So you can kind of see it here. That gusset plate is like that big thing keeping them all together. So some bridge failure observations, and so this is where, like a scientist, they would write down their observations that they saw. After the bridge collapsed, the local sheriff's department handled the initial recovery of the collapsed bridge structure. Finding, freeing, and identifying victims was a high priority, and an unintentional damage to the collapsed bridge occurred in the process. However, investigators eventually recovered the entire structure. The investigators labeled each part with the location where it was found. They also noted the date when they removed each piece. Investigators then moved the pieces to a nearby park where they placed the pieces in their relative original positions. Examining the reassembled structure, investigators found physical evidence that they needed to determine where the breaks in each section occurred. The investigators found more clues in a video. A motion-activated security camera recorded the bridge collapse. The video showed about 10 seconds of the collapse, which revealed the sequence of events that destroyed the bridge. Investigators used this video to help pinpoint where the collapse began. Asking questions. One or more factors could have caused the bridge to fail. Was the original bridge design faulty? Were bridge maintenance and repair poor or lacking? Was there too much weight on the bridge at the time of the collapse? Each of these questions was studied to determine why the bridge collapsed. Did one of the combination of these factors cause the bridge to fail? So, gathering information. Investigators reviewed the modifications made to the bridge since it opened in 1967. In 1977, engineers noticed that salt was used to de-ice the bridge during winter. Weather was causing the reinforcement rods on the roadway then to weaken. To protect the rods, engineers applied a thick layer of concrete to the surface of the bridge roadway. Analysis after the collapse revealed that this extra concrete increased the dead load on the bridge by about 13.4%. A load can be a force applied to the structure from the structure itself, the dead load, or from a temporary load such as traffic, wind gusts, or earthquakes, which is a live load. Investigators recorded this qualitative and quantitative data. Qualitative data uses words to describe what is observed. Quantitative data uses numbers to describe what is observed. So let's add that to our vocab here. So qualitative uses words to describe. I'm going to pause here so that you can make sure you've got all of your vocab. We're going to head to the questions when you join me on part 2 of this video.